Alright, let's have a look at question 9. It's a question about a generator, and you're given a diagram. Notice that the two brushes are attached to two pieces of wire that then are drawn off, and there's no battery there. So this is a generator, this is a device that's going to create electricity, not a motor that's using electricity to create motion. Alright, first question, is the output AC or DC, and give a reason. The key here is the presence of slip rings, and that tells us that it's an AC generator, and the reason is that slip rings have been used, or you could justify by saying that the current alternates every half turn. 9.2, two effects on the output voltage if the coil is made to turn faster. If the coil turns faster, then the first change is that there will be an increase in the maximum voltage, Vmax, because the rate at which the magnetic flux is changing will increase. And then secondly, there will be an increased frequency. In other words, the number of turns that the coil makes per second obviously increases, and therefore the frequency of the AC will increase. So those are your two effects of an increase in the speed of the coil turning. 9.3, what's the position of the coil relative to the magnetic field when the output voltage is a maximum? Remember, there's the magnetic field running from north to south between two fixed magnets. Between the magnets, they're parallel, and so we're interested in at what position of the coil is there a maximum voltage, and the answer there is that when the coil is moving at 90 degrees to the magnetic field, you have a maximum induced EMF. So you have your Vmax when the coil is in the horizontal position, or you could describe it when the coil is moving at 90 degrees to the field, and that's obviously when it's in the horizontal position. Alright, 9.4, the purpose of the brushes. There they are, shown in the diagram. And their purpose is to maintain electrical contact between the slip rings and the wires that are drawing off the current. You could also describe that their purpose as to draw off the induced current. 9.5 speaks about coal-driven generators are a major source of electricity, and the proposal that we have or invest in more windmills as an alternative source of energy. And so you ask for one advantage and one disadvantage. Firstly, advantages. It obviously provides a renewable source of energy. It's got a low carbon footprint, which means it doesn't release carbon dioxide or any other gases in terms of its actual generation. Disadvantages, some to consider there. It's not a dependable source of energy because of the variability in wind speeds. It provides visual pollution in the area that they're put up, and they often have to be located, because of the previous point, in remote areas, which means that they're difficult to service and obviously need to send electricity along long distance wires to get them into areas in which they're needed. Alright, 9.6. Got an output of an AC generator shown in a voltage time graph. A light bulb is connected with a power rating of 100 watts. And it asks you for the RMS potential difference across the light bulb. First thing to recognize is that the value given there is your Vmax, your maximum voltage, 311.13 volts. And so the formula we're using is VRMS, is Vmax over root 2. And if you calculate that correctly, you get a RMS value for the potential difference of 220 volts. 9.6.2, the peak current, or Imax, through the light bulb. We use our power formula. Power is voltage times current. Our power is given as 100 watts. VRMS we've just calculated to be 220, and so we can solve for IRMS to be 0.45 amperes. But the question asks for Imax, and so Imax is IRMS times root 2, and if we calculate that we get 0.64 amperes.